Good day to everyone. My name is Sriniketan. I am currently studying Masters in Construction Engineering and Management at CEP University. My student code is PCM25338. I am glad to present my feasibility study of the Integrated Textile Park. The Integrated Textile Park is being developed by Gujarat Industrial Development Corporation under the public-private partnership and design build finance operate transfer model with GIDC holding 51% of equity and Ministry of Textiles holding 49% of equity in the special purpose vehicle. This integrated textile park project is initiated by the Government of India on special purpose vehicle concept through partnership of Industrial Development Corporation of the states. The project has an estimated cost of 3 rupees 3567 crore, including a 500 crore rupees of viability gap funding, and the construction duration of the project is planned for 5 years. The project is then currently at the tender stage following the detailed project report submission in March 2022. The project is strategically located on a 1142-acre site in Jalalpur Taluka, Navsari district with strong connectivity via NH48 and Navsari railway station, Surat airport and Hazira port. This integrated textile park is designed as an integrated mega textile park based on the 5F concept from farm to foreign. The objective of this initiative by Indian government is to emphasize an efficient supply chain and thus a cost-effective manufacturing environment. This project offers plug-and-play industrial infrastructure, efficient connectivity, and ready industrial plots supported by common facilities. It also includes social and support amenities such as administrative spaces, worker dormitories, and healthcare facilities, along with the opportunities to generate 2 to 3 lakh jobs focusing on sustainability. This industrial This integrated textile park integrates with eco-friendly planning, robust utility systems for power, water, and ICT, and aims to reduce logistic and production cost. This project aligns with the UN SDG 9 goal by promoting industry, innovation, and modern infrastructure. India is the second largest textile export nation with the focus on integrated manufacturing and high quality textile products. The integrated textile park project involves various stakeholders involving government authorities, funding agencies, developers, project management consultant and contractors, industries and customers. Stakeholder management is studied through power interest matrix and the influence impact matrix. This helps project management engaging all stakeholders and ensuring close monitoring, keeping the strategic stakeholders informed and satisfied. Power interest matrix for the integrated textile park highlights that the most influential stakeholders fall under the manage closely category, including the Prime Minister's Office, Ministry of Textile, Apparel Export Promotion Council, and Gujarat Industrial Development Corporation, reflecting their high power and high interest in this project's success. Stakeholders with high power but lower interest, such as the maintenance department, structural consultants, and MEPF consultants, and urban planning consultants, are placed under the keep satisfied portion, requiring periodic engagement to maintain the alignment. The, the FDA agencies fall under the keep informed category, indicating low power but high interest and requires regular communication and updates. The influence impact matrix for the integrated textile park shows that the most critical stakeholders fall under the managed closely category, including the Prime Minister office, state government, key industrial units, and major investors, as they hold both high influence and high impact on the project's decisions. High influence but lower impact stakeholders such as the city planning department, selected consultants, major retail chains, and key suppliers are positioned in the keep satisfied zone, requiring periodic coordination to maintain the support. Cluster promotion agencies, master planning consultants, industrial units, and service vendors fall under the keep informed category, reflecting their lower influence but high impact. Necessitating regular updates and engagement is required for these stakeholders. Meanwhile, community organizations, smaller suppliers, design consultants, and smaller industrial units lie in the monitor category as they have low influence and low impact, requiring only minimal monitoring. Overall, this influence and impact matrix indicates that strategic and regulatory bodies drive this project outcomes, while smaller industries and community groups play supportive roles but less influential roles in the successful development of this integrated textile park project. Breakdown structure for the integrated textile park outlines the comprehensive responsibilities of the project management consultant across all the project phases. The phases such as pre-construction phase, then construction phase, and control and reporting phase, commissioning and O&M phase. In pre-construction phase, the activities such as assisting the EPC contractor selection and ensuring consultant coordination and statutory design compliance. During the construction phase, the project management consultant oversees the EPC works related to CETP, buildings, power, water infrastructure, and ensures adherence to the labor laws and monitors schedules, milestones, and quality control. In the control and reporting phase, the responsibilities include submitting the regular progress reports to the SPV, tracking the risk register, and advising the master developer on how to mitigate the risk and all, and managing the contracts, disputes, and arbitration. The commissioning and O&M phase involves supervising the commissioning of utilities and buildings, carrying out testing and performance verification, certifying completion and handover, assisting in O&M, manual preparation and monitoring during the defect liability period. Overall, the structured WBS for PMC ensures effective supervision, strong quality control, timely reporting, and a smooth transition into operations and maintenance. This structured division ensures consistent quality control, timely progress monitoring, and smooth transition into operation and maintenance during project handover. The work breakdown structure for the integrated textile park outlines a comprehensive multidisciplinary design framework coordinated under the master developer. It details the roles of architectural consultant, structural consultant, MEPF consultant, landscape consultant, surveyor, and geotechnical consultant, covering all stages from design brief and statutory complaint layouts to tender drawings, approval drawings, GFs, good for construction drawings, and site coordination. Each discipline contributes essential outputs such as structural stability certificates, HVAC and utility layouts, electrical and plumbing networks, fire safety systems, landscape concepts, and geotechnical investigations, ensuring that all the design components align with the regulatory requirements and project objectives. This structured breakdown enables seamless integration of design deliverables, clear accountability among consultants, and efficient execution throughout the project's design development phase. Choosing by advantages, we evaluated two critical design problems through choosing by advantage on the common effluent treatment plant technologies in integrated textile park and soil stabilization methods for textile processing zones. The choosing by advantages analysis for the common effluent treatment plant technologies in integrated textile park combine compass sequential batch reactor, membrane bioreactor, and membrane membrane bed biofilm reactor technologies based on the critical criteria such as water reuse, return on investment, energy consumption, membrane life, and then biological oxygen demand and chemical oxygen demand removal, and the required footprint. Among the three options, the membrane bioreactor achieves the highest overall advantage score of 530 due to its superior water reuse potential, shorter return on investment period, and higher membrane life and excellent treatment efficiency. Although SBR performs well in terms of energy consumption and offers a lower overall cost, and MBBR provides a balanced performance with moderate scores. Both technologies fall short in long-term scalability and reuse capability. MBR emerges as the most advantageous CETP technology for the integrated textile park, offering better operational performance, reuse use quality, and long-term suitability despite its relatively higher cost. For CETP, we conclude on MBR technology offers stronger long-term suitability, achieving the required low total dissolved solids norms. The choosing by advantages analysis for soil stabilization in the integrated textile park shows that deep soil mixing provides the highest overall advantage score of 440, making it the most suitable technique for the site's saline marshy soil conditions, with the ability to increase the safe bearing capacity from 130 kilopascal to 420 kilopascal, and it reduces the settlement to as low as 6 mm and deliver superior compressive strength and durability. It is ideal for supporting large industrial buildings and heavy load infrastructure. Stone columns score moderately at 325, offering good performance in settlement control and durability, but with lower strength improvements compared to the deep soil mixing. Cement stabilization with the lowest score of 280 provides minimal improvement in soil strength and therefore best suited for lighter structures such as peripheral roads. Overall, the deep soil mixing emerges as the most advantageous and reliable solution for achieving stable and durable ground conditions across the integrated textile park. Project baseline schedule for the integrated textile park is developed based on a planned start date of 28 July 2025 with the standard working hours from 9 a.m. to 1 p.m. and 2 p.m. to 6 p.m., excluding the major public holidays such as the Independence Day and the Gandhi Jayanti, Holi, Diwali, Republic Day. The integrated textile park timeline defined in baseline schedule with a phased project flow from mid 2025 to early 2030 with design consultants involved from early durations that feed into longer construction period handled by civil CETP, various MEP and infrastructure contractors. The master developer and the project management consultant span the full project cycle to maintain coordination and ensuring the targeted output. In conclusion, the integrated textile parks planning framework demonstrates a well coordinated and structured approach across stakeholder management, work breakdown structure, choosing by advantages, and project baseline schedule. In stakeholder management, the stakeholder management ensures clear roles and alignment and effective coordination among government agencies, industry partners, and community bodies enables a smooth project execution. The work breakdown structure brings clarity, accountability, and seamless coordination across all project components and disciplines, strengthening project governance. Through the choosing by advantages method, the MBR based CETP technology and deep soil mixing were identified as the most advantageous options, offering the sustainable solutions, high durability, and strong ground stability for long-term infrastructure performance. The project baseline schedule supports the timely delivery by enabling the accurate planning, efficient coordination, and systemic monitoring of all project milestones. Collectively, these tools establish a robust foundation for the successful development and implementation of the integrated textile park. I thankfully conclude my study on the stakeholder management, work breakdown structure, project baseline schedule, and choosing by advantage on common effluent treatment plant technologies and soil stabilization. I thank the SEPT University and faculty members for this wonderful opportunity. Thank you.